Hi everyone, myself Jahnavi. So today I'll be taking about the clipping concepts in computer graphics. Before we start with the line clipping, we'll see what is meant by point clipping. So we need actually a window that defines what to be displayed. That defines what to be displayed. So what is clipping then? So clipping discards the portion that lies outside window. So we call that as clipping. So there are point clipping, line clipping, and polygon clipping. Line clipping, there are two algorithms, Cohen Sutherland and Barsky. Whereas with respect to polygon clipping, we have Sutherland Hodgman algorithm. Before we start with the clipping, we had to define a window before we start the clipping procedure. Example, consider this as a window. So I can call this as y min, yw min, yw max and xw min. So this will be xw max. Consider I have a point here or else here. If any of the point, I can call this as x. So if my point is lying between this clipping window, example, let's assume there is a point here, the coordinates are x comma y. With respect to this point, if the coordinate x is lying between xw min and xw max, or y coordinate if it is lying between yw min and yw max, then I have to consider if this condition satisfies, point lies in window boundary or within window, so accept the point, consider the point. If not, will be based there are few conditions, then we may reject the point. Assume there is a p dash here, so of course its x value will be more than xw max and even the y value might, yes, it lies between this range, whereas x, no, it doesn't lies. So I will reject this point. So this is about point clipping. We'll see about line clipping now. So before we start with any clipping, yes, we have to define a window with its boundaries as we have seen here. So I'll draw one more window just for the understanding point of view. Let's assume I have a lines here, P1, P2, P3, P4, line that is cutting this boundary, P5, P6, something which is passing like this, P7 and P8. Fine. Before we run the algorithm, using our the common sense, yes, we can say P1 and P2 is lying outside, so I'll reject the line. Whereas P3 and P4, it is lying inside the boundary, so P3 and P4 I will accept it. P5 and P6, for P5 and P6, yes, we have to apply the clipping concept. So clipping concept is required here. We need to apply it. How about for P7 and P8? Even for P7 and P8, clipping is required. Fine. First, we have to consider the end points and apply the point clipping. If both P1 and P2, there are few conditions, if doesn't satisfies, then we'll be rejecting the points. If either of the one point satisfies the conditions of this, see, let's assume I'll take this point. This, both the points X and Y doesn't satisfy these conditions, so I'll just directly reject the line. If I take this P5 and P6, P6 satisfies this condition both. P5, no. With respect to Y, yes, it won't satisfy. In that case, I have to calculate the intersection point, then I have to apply the clipping algorithm again. So before we start, for this we make use of Cohen Sutherland algorithm. Cohen Sutherland algorithm runs based on region code. Region code. Example, the region code could be above, below, right and left. Instead of above, you can replace with top also. Top, below, right and left. So I'll take it above itself. So it's a 4-bit code. So how it works means, assume for this region code, here the points for this region code, above, no, it is not above, this region is not above, below, no, right, left, 0. So the code for this region is 0 0 0 0. Let's take this one. For this is not above, this is not below, of course this is right side, and this is not left. Consider this region now. This region is not above, neither below, neither right, actually this is towards the left. Consider region that is present here. This is not above, this is below, this is not left or right, this is the center actually. And here, with respect to region code, of course this is above, this is neither below, right or left. Can I just go with this? This is above, this is not below, and this is not left, this is right. Okay, so try writing the code for this region code. This is not above, this is below, and this is not left, this is right. Okay, come for this side. So this is not above, this is below, and this is not right, This is left region. And how about this? This is above. This is not below. This is not towards right side. This is the left region. So taking this codes, let's say for point P1. So can you just say the region code? It is 0, 0, P1. Where does the P1 lies? It is lying here. Correct. So the region code is 0001. How about for P2? Let's assume these 2 points are here. For P2 it is 0001. It's the same. Correct. The same way, can you just say the region code for P3 and P4? For P3 the region code is 0000 and for P4 also it is 4 zeros. How about for P5 and P6? For P5 the region code is can you just say me one thing? This is 0 above. I made a mistake. So P5 region code is 1000 and for P6 it is 000. How about for P7? It is 0010 and for P8 it is 0100. So I have taken the region codes here. Before we actually go into this, we just see a pseudocode. Fine. So what does it says? Cohen Sutherland pseudocode. Cohen Sutherland pseudocode. If first step is assign the region code for the endpoints of a line. Yes, we have done it now. If the region codes of the endpoints of a line is 0, then the line is accepted completely. So which one comes under this category? P3 and P4, where in which those region codes are completely 0. So I'll be accepting this. Fine. What if both the region codes are not 0 of the endpoints of a line? Else perform logical AND operation for both region codes. Assume I have applied an AND operation. If the result is not equal to 000, reject the line since the line is outside. For this, we'll take an example of P1 and P2. This is completely falling outside the clipping window. So as I said, if both the endpoints region codes are 0000, accept it. Else perform an AND operation. Perform an AND operation. 1 is 1, 0 0 0. So this is non-zero. So in that case, reject the line. Correct. Now come back to the code, pseudocode. I'll just read out again. If the region code of the endpoints of a line is 0000, then the line is accepted completely. Else perform logical AND operation for both region codes. And if results is not 0, reject the line since the line is outside. Else line is partially inside. Means for P5, P6 and P7, P8 points, this line is partially inside and partially it is outside. So what you have to do in that case? Choose an endpoint of the line that is outside the region rectangle window. Example, For this line, this is lying inside the window, clipping window. I won't consider this. I have to choose P5 that is falling outside the clipping window. Correct. So choose an endpoint of the line that is outside the given rectangle window. Find out the intersection point. Okay. Replace the endpoints with the intersection point and update its region code. Example, instead of P5, I'll take P5 dash. So in that case, P5 dash region code will be, if it is on boundary, it will be 0 0 0 0. Now take P6, it is 0 0 0 0. Perform the, means if both are 0, yes, I have to accept the line of P5 dash and 6, means the region from here to here will be clipped. I'll be drawing only this line. Fine. Come back to the pseudocode. Repeat step 2, means here, until the line is accepted. Else reject. Repeat step 1 for other lines to find the intersection point. So we have one more line here, P7 and P8. Hope you can see. Since on performing the AND operation of this both, it is Z. Can you just perform the 0 0, it is 0, 0 1, it is 0, this is also 0, and this is again 0. If you get 0, actually it is partially, means okay, you can do in this way. Hold on one second. So we get 0. Actually we can draw a truth table from this, that helps for the programming part. For time being, for this line we have to find an intersection point P7 dash. So P7 dash will be 4 zeros and P8 will be 0 1 0 0. So this both are, P7 dash is 0, but P8 is not 0 to accept it completely. Find the intersection point, that is P8 dash. So in that case, P7 dash is 0 0 0 and P8 dash is all 4 zeros. Now you can accept this line, where in which this will be clipped and will draw only this portion, P7 dash to P8 dash. Now there should be a logic to find the intersection point.